Swayam Prabha. Digital India. Educated India.
DAV School, Uppal South End, Gurugram, comprising of Ashima Kalra of grade 12 and Shreya Pandey of grade 12. Let's welcome them.
Greetings everyone. My name is Ashima Kalra
And I am Shreya Pandey,
and we are the students of
DAV Public School, Sector 49.
Fasten your seatbelts and get ready as we take you through an interesting journey exploring the magical circular motion.
Let's begin with some fun experiments.
Come on Shreya, let me show you the dancing marble.
Wait. Did the ball just defy gravity for some time? Why did this happen?
Yes, it did. Well, hold your horses. Now, can you see this coin which is continuously swirling inside the balloon?
Yes. But why did this happen?
So, the concept behind these two experiments is the centripetal force, derived from the Latin origin, centrum meaning center and petus meaning seeking. It's the center-seeking force. And objects generally have a tendency to move in a straight line path. But to make them move in a circular path, we require a force, and this force is what we term as a centripetal force.
Now, let's conduct an experiment to find out the direction of the centripetal force. So, Ashima is just going to rotate the setup.
I want you all to focus on just one candle and it will turn inside, that is towards the center. Can you see the flame of the candle turning inside?
Yes. Did you see that the candle flame always pointed towards the center, irrespective of where it was in the circular path? Simply put forward, centripetal force is like a magic rope, always pulling the object towards the center, preventing it from flying away. Now, let's get out of our textbooks and find out where all we can find centripetal force around us. Now, let's get out of our textbooks and find out where all we can find centripetal force around us. Centripetal force can be provided by various agents such as tension, friction, gravitation, and even electrostatic forces.
Let's demonstrate the first one for you. We'll simply spin this object around. So basically, the object is spinning because of the tension in the string. And as soon as I stop spinning it, you can see that it will go tangential to the circular path. I'm not leaving it because it will fly away right now. So in this case, the tension is the agent for the centripetal force.
Ever wondered why the hula hoops go round your waist without falling down? The answer is simple. The frictional force and the normal contact force from a body are the agents of the centripetal force in this case, and they prevent it from flying away.
Yeah. And can you tell me the reason why the planets revolve around the sun in their almost circular orbits? Yes, the gravitational force. That is the agent of centripetal force here.
Centripetal force is even present at the microscopic level. For example, electrons revolve around the nucleus in their orbits because of the centripetal force provided by the electrostatic attraction between the electrons and the nucleus. How fascinating, isn't it?
Yes, of course. Now let's put your knowledge to test. Can you identify the agent in the initial activities we performed, the dancing marble and the swirling coin?
Yes. Is the answer frictional force and the normal contact force?
You're absolutely right.
Yes.
Alright, let's first dive into some technicalities of the centripetal force. Imagine an object is moving in a straight line path and I apply a force perpendicular to it. It deflects a little. I again apply a force perpendicular to it, it again deflects. And if I continue the same process over small time intervals, the path so formed will be a polygon with infinitely many sides, right? But this is nothing but a circular path. So we can notice that whenever objects move in a circular path, the force is along the radius, the velocity is along the tangent, and they're always perpendicular to each other.
So remember, whenever objects spin or swirl, it's the centripetal force that unfurls. Now, moving forward. Ashima, can you fly away these coins from this table without touching them?
Yes, it's easy. See?
Did you notice that the coin farthest from the center of the table flew away fastest and had even more range than the other coins?
Yes, but why?
The reason behind is simple. The tangential velocity directly depends on the angular velocity and the radius. But in this case, the angular velocity of all the coins is the same. So the radius is the determining factor.
And therefore, the coin which was placed farther from the center flew faster and had more range. But wait. Why did the coins even fly away in the first place?
Be patient. Let's experiment once more to find out the reason.
So here we have the mini version of a sprinkler here. Can you see the water is splashing around all over the container? Why? Yes, the reason is centrifugal force.
All right. We spoke about centrifugal force. But what is it exactly? Let's break it down for you. Centrifugal force is a perceived outward force experienced by an object in circular motion. It arises due to object's inertia, resisting change in direction and thus creating the illusion of a force pushing outwards.
Oh, I see. But we won't bore you with the theory, so let's conduct some more experiments and show you this. So as you can see here we have an apparatus with some objects in the center. And as Shreya rotates this experiment, you can see the objects come towards the end of the apparatus. But who pushes them? Yes, it's the centrifugal force.
As Ashima rotates the setup, the balls go towards the diameter and stays along it for a few seconds. But why did this happen? Yes, the centrifugal force.
All right, one more experiment, Shreya. So herein we have this simple setup and we have oil and colored water in these two bottles. You can see them separated out slightly. Now as I rotate this setup, look very carefully, there is a curve like this which is formed. That is because of the resultant of the centripetal and the centrifugal force. Also notice that the water will move towards the edges because it has slightly higher density than the oil and thus has more rotational inertia, and therefore the force acting on it is also more. Let me show you once more.
Yes, I do
Notice
see
the curve.
Yes.
Exactly. All right, lot of theory. So, अच्छा वैसे तुम बहुत कमज़ोर हो गए हो, मैंने नोटिस किया है. कुछ खाया पिया करो, माखन खाया करो.
हाँ, कमज़ोर तो तुम भी हो गई हो, तुम्हें भी खाना चाहिए.
हाँ, ठीक है. वैसे इससे मुझे याद आया, माखन भी सेंट्रीफ्यूगेशन से नहीं बनता.
बिल्कुल सही. सेंट्रीफ्यूगेशन करके ही तो माखन भी बनता है.
राइट. अच्छा, आज अम्यूजमेंट पार्क चले, थोड़ा बोरिंग सा डे है.
चलने को तो चल सकते हैं, लेकिन मैं झूलों पर नहीं बैठूंगी. मुझे डर लगता है कहीं मैं गिर ना जाऊं.
तुम भी ना इतना सेंट्रीपिटल सेंट्रीफ्यूगल फोर्स पर बात किया, फिर भी साइंस पर भरोसा नहीं है.
बात तो सही है.
अच्छा.
There are many more daily life applications of centrifugal force. Some of them are washing machines, swirling water in a bucket, separation of the components of blood, and many more. Ashima,
Yes, Shreya.
let's take a fun break. It's all boring now.
हाँ, बहुत हो गई पढ़ाई शढ़ाई, थोड़ा खेल करते हैं. चलो ਹੁਣ ਅਸੀਂ ਦੋਵਾਂ ਕਿਕਲੀ ਪਾਉਂਦੇ हैं.
चलो जी.
So as you can see, the tension due to the contact of our hands and also the frictional force provided the necessary centripetal force. And also we felt like we were being pushed away from the center, almost as if we were about to fall. That was because of the centrifugal force.
वाह, खेल में भी विज्ञान. चलो एक और खेल से ही समझ लेते हैं. In this activity, we have tied a lightweight object to the hula hoop.
So can you see that the hula hoop spins around my waist and the object moves away?
Yes, the reason behind is the frictional force and the normal contact force from Ashima's body was the reason because of which the hula hoop was going around her waist. But the object is moving away from the hula hoop because of centrifugal force.
Okay.
Now,
one more last experiment for you guys.
Time for some mind-bending magic, or I should say some strip-bending magic. Let's see. Here we go.
Ah, I see. Can you guys also see those interesting curvaceous patterns which are being formed as she rotates the stick around? Let's see it once more. It goes up and down. See this pattern.
The reason behind this is also centripetal and centrifugal force. The centripetal force keeps the strips attached to the stick, while the centrifugal force tries to push them away. They both go hand in hand to create these beautiful, interesting patterns.
Curvaceous patterns. All right, to conclude, remember, it's the centripetal force that pulls you in and the centrifugal force that pushes you away.
Yes.
And they work together in perfect coordination to move things in a circle.
Yes, it's like a balancing act between them that makes the objects go around a circular path.
Thank you for being keen listeners.
And remember to always and always keep experimenting.
Keep your science hats on. Thank you.
Thank you.
Now we have TMB comprising of Shwetang Agrawal of 10th grade and Mukul Yadav of 10th grade. Let's welcome them.
A very good morning to one and all present here. Today I, Shwetang Agrawal,
And I, Mukul Yadav,
have come here from DAV Sector 49, Gurugram, Uppal South End to delight your minds and fill you with exuberance with a bombastic presentation on centripetal force. In the realm of physics, motion is often perceived as linear, yet the intricacies of circular motion reveal a captivating force at play, the centripetal force. This force, although unseen, governs the motion of celestial bodies, the trajectories of a spinning top, and the exhilarating curves in an amusement park ride.
centripetal force, stemming from the Latin words centrum, which means center, and petier, which means to seek, explains the tendency of an object to move in a curved path focused on the center of the path.
But it all sounds so obscure. How did they even get at this idea?
Wait, Shwetank, let's talk about history. So, Aristotle proposed that circular motion is the most perfect form of motion, and all the planets revolve in circular orbits due to their divine nature. Though it was later discovered that they do not move in circular orbits, they move in elliptical orbits.
I remember now. My history teacher once told me that Archimedes' work laid the foundation and the groundwork for concepts related to balance of forces and mechanics related to simple machines. But I am not a history student, I am a science student. I want to see some fantastic experiments.
Wait, Shwetank, I have some experiments.
Oh, seems like a best out of waste one. But my brain can't process. What's happening?
Wait, I'll explain it later.
Oh, did you think you were the only one with an experiment? He thinks he's the smart one. I've got something up my sleeve as well. Let me show you my ballerina. And voila, it works like magic.
But what is happening here?
Mukul, let me cook. Let me cook. Let's dive deep into the concept of centripetal force. Now, the term centripetal force was coined by Sir Isaac Newton in 1687. Let us talk about velocity for a bit.
Velocity is a vector quantity which has both magnitude and direction. It is the speed in a specified direction and the rate of change of displacement.
That means velocity is a vector quantity. So, in the case of linear motion, the picture is quite simple. As the direction is specified, the object keeps moving in a specified direction, even though its magnitude may change due to one or the other forces acting on it. But one thing to remember is that the direction stays the same. Let's talk about acceleration now.
Acceleration is the rate of change of velocity. So if the velocity changes, obviously the acceleration will change.
And a change in velocity can be marked by only two things. That is, a change in magnitude or a change in direction. Let's look at this circle for now.
So as you can observe, square has 4 sides, pentagon has 5, hexagon has 6, and so on. So if we observe a polygon of infinite sides, each length of each side would tend to be 0.
That is, they would be reduced to mere points. Let us recall the definition of a circle. It is the locus of points all equidistant from a given point. Don't the two sound awfully similar?
Yes, Shwetank, because circle is a polygon of infinite sides.
That is why, in the case of circular motion, the picture becomes a bit more complex. In circular motion, the velocity at every point on the circle is tangential to the path of the circle. That means that at every point, the velocity changes because the tangent to the circle changes, i.e., there is a change in velocity.
And if there is a change in velocity, it means that there is some acceleration. According to Newton's second law of motion, F equals to ma, that is, force is equal to mass into acceleration. So, force is directly proportional to acceleration. If there is acceleration, then there must be some force.
And this force, ladies and gentlemen, is the centripetal force we've been babbling about for the last 5 minutes. The word centripetal force was given by Sir Isaac Newton, and we must know how to find its direction then. Well, it's pretty easy. In a circular path, in uniform circular motion, the magnitude of velocity stays constant even though the direction changes. This is only possible if there is a force perpendicular to the direction of the velocity, as we can see here. That means that the force is always perpendicular to the direction of the velocity, i.e. it exists in a radial direction directed towards the center.
And Shwetank, I read about some centrifugal or centrifugal force something.
It's not centrifugal. It's because you read rubbish. Centrifugal force, oh God, you've spoiled my tongue. Centrifugal force is a pseudo or imaginary force which is used to imagine an object moving in a non-inertial frame in an inertial frame.
And it has the same expression as of centripetal force, that is mv square upon r or m omega square r.
Now let us use our newfound superpowers of knowledge to explain some phenomena that we just saw.
So, in this experiment, we can observe, it seems like there is some force being exerted from the center on the aluminum balls towards both of the walls. but let's check about it, that there is not a centrifugal force, there is a centripetal force being exerted by the normal from the walls towards the center on the objects.
Now let's revisit my ballerina, shall we? As we can see, this apparatus is known as a homopolar
Wait,
motor.
but where is the centripetal force here?
Wait a second, Mukul. How many times have I to tell you that you must keep a little patience? As we can see in this apparatus, there is a cell, a 9-volt battery, some magnets and a copper coil. When I connect this apparatus, it spins. But at first glance, it looks like charge is flowing, charge is getting accumulated, force and all that, blah, blah, blah. But once we examine it closely, we derive an important fact. Magnets are conductors, aren't they? That means that it is a closed circuit. A current is flowing in this circuit. When we examine this coil, we see that from the negative terminal on top of the battery, there is the connection towards the magnet, i.e. charge is flowing in an upward direction. Let's use Fleming's left-hand rule. Charge is flowing in an upward direction, magnetic force exists in the radial direction, and there is a force on the left side. That is how it's spinning. Now, let's see some more common folk experiments regarding centripetal force.
So let's move to our other experiment or a game we must have played in our childhoods.
Whoa, you're strong, Mukul.
Okay, so here we can feel that there is a force being exerted on our hands towards our body from this circular motion and from the center. And this force, it seems like it is a centrifugal force. But as we know, according to Newton's third law of motion, action is always equal to reaction. So there is a reaction force from our body towards our hands to the center of this circular motion. And this force is, ladies and gentlemen, centripetal force.
Well, this is all common folk, but do you know what my favorite chapter in physics is? It's magnetism. So let's examine another of my ballerinas, the magneto-ballerina. In this apparatus, we have a pencil, a magnet attached to it, and a disc magnet. When I spin this, it spins vigorously.
Shwetank, I know it's a circular motion, but where is the centripetal force here?
Mukul, keep a little calm, man.
Sure.
Now, let's look at this. Here, we know that magnets exert a force known as magnetic force. Well, magnets have like poles and unlike poles, north and south. So, like poles repel and unlike attract. When I check this, it's repelling. That means that there is a force from the magnets towards the center. Rang a bell? Centripetal force it is. But the concept of centripetal force is not so measly that it can be confined into such lowly experiments. It exists on a grand scale, as grand as the universe.
So, in the new universe, our dear solar system, we all know that planets revolve around the sun. But do you know how they revolve around the sun with which force? So, this force is the gravitational force. And ladies and gentlemen, this gravitational force is nothing but the centripetal force.
Now, let's examine another common problem that scientists faced a little while ago. So, for many experiments, scientists had to accelerate elementary particles, which are electrons, protons, alpha particles, to very high speeds. How do we do that? Electric field. But by using an electric field, it would require kilometers of wire, a lot of stuff, and hefty measures. That's neither time effective nor cost effective. So, what did they derive? Centripetal force. That's the solution. Here you can see is a cyclotron. A cyclotron is a device, only two of which exist in India. One is in Punjab University and other in the revered University of IIT Bombay. When you consider this apparatus, there is a magnetic field existing into the plane. In the hollow space between the two hemispheres, there is an electric field. So let's see, I leave an electron inside, poor guy. When I leave the electron inside, it gets accelerated. Then it exerts in the magnetic field. Since the electron is moving towards the right direction, I can consider the current towards the left. So let's use Fleming's left hand rule again. This is the direction of the current, this is the magnetic field, and this is the force. i.e. the force will always be perpendicular and directed southwards. Thus, it would rotate in a circle, get accelerated, rotate, rotate, and rotate, and there goes that electron. I like that one a lot. I'll miss that one.
Okay, so let's move to our next example. That is mixer or grinders. We must have consumed juices, smoothies or shakes.
Mukul, don't talk about that. I'm getting hungry.
But we need to talk about it. So, there we grind them. But do you know, in those machines, there is a circular motion and there is a force which looks like there is a centrifugal force from the center of the mixer or grinder towards the vegetables or fruits. But even here, there is a normal force being exerted from the walls of the containers or the machines towards the vegetables and fruits on the center. And this force is the centripetal force.
And how can we end without the esteemed model of the atom given by Niels Bohr? When we consider an atom, there is a positively charged nucleus in between, consisting of nucleons, which are protons and neutrons, and electrons are moving around in orbits. When we look at this, it's circular motion. That rings a bell. Centripetal force must be there. But what's the agent? Well, I'll say electrostatic force, whose expression was given by Sir Coulomb, being k q1 q2 by r square. Since these are unlike charges, positive and negative, therefore they exert an attractive force towards the center. That means that there is a force towards the center in all times. That means it is the centripetal force we've been talking about. Now, I would like to conclude, but we see that centripetal force can exist in small experiments like these or as grand as the universe.
And we hope that you learned about many things about centripetal force and would like to learn much more.
May the force be with you. Thank you.
Now we have Delhi Public School, Greater Noida, presenting on the topic Centripetal or Centrifugal Force. We first have Team A, comprising of Vidhi Rao of grade 11th and Samishta Jindal of grade 11 as well. Let's give them a big round of applause.
Discovery is seeing what everybody else has seen and thinking what nobody else has thought. Namaste everyone. Today I, Vidhi Rao,
and I, Samishta Jindal,
the youth of New India,
welcome you
to our fascinating realm of everyday science.
Now, we would like to take an opportunity to thank the Education of India, your innovation cell, for this opportunity, because we firmly believe in experiential learning is the key to success. From our morning's first light to our final night, science stands with us, a constant friend in life.
So let's decode the scientific miracle. Everyday science from our lens, a little practical. So here we begin with our presentation on the topic centripetal and centrifugal forces. Well, this is how a typical day before the birth of Christian Huygens looked like.
God, yeah, why is mopping this floor such a tedious task? It feels like I will have to spend centuries collecting this lather.
My gosh, can you stop that hairdryer? It literally feels that my scalp is burning.
This is too tiring. Time out. Bujo, come on, let's play tickly.
Your wish, my command. words.
I'm so sorry. I don't know why am I always so bad at gripping. In fact, why do we even have to grip while moving in a circular motion? Did you see the huge chaos in Paheli's life? And all this is attributed to the two forces,
Centripetal and centrifugal force.
Who thought that something as trivial as just a small paragraph in the class 9th NCERT can have such a huge impact in our lives?
So now, let's revisit that symbolic scene from the movie Mission Mangal. Had there been no centrifugal force, the great minds of ISRO would not have been able to take India to Mars. Alright, I am Earth and you are?
Your son?
No.
Mars?
Yes. So our rocket PSLV can take the satellite till here, that is the gravity of the Earth.
Careful, Mom, it will break.
That is what we want. As the force increases and increases and increases, it will overcome the gravity and...
Damn, Mars will catch it, right?
Exactly. That is what centrifugal force is all about.
It is an apparent force that acts outwards on an object moving in a circular motion. It acts along the radius and is directed away from the center of the circle. Don't worry, let's break it down. So in our example of our rocket PSLV, this is our rocket and this is Earth. As on the big day, we release this rocket, it moves in a circular motion around the Earth. Right now, it is experiencing an outward force in the direction of the tangent. But this force is too small in front of huge Earth's gravity. But as it moves and moves, this force increases and increases and finally, it is able to overcome the Earth's gravity. Yes, my friends, this outward force was nothing else but our centrifugal force.
But as we know, life is like a rose, none without thorns.
Okay, tell me what comes to your mind when I say issues in Delhi?
Those huge garbage mountains in Ghazipur?
Indeed.
They have become 65 meter high and have almost reached the height of the Qutub Minar. Just to give you a comparison.
And the best solution to them are the waste to energy plants. A total of 14 waste to energy plants have been set up in India, out of which 7 were closed, said Swati Singh Sambhyal, an independent waste management and circular economy expert.
Then, out of curiosity, we dived more into the depth of the reason behind the failure, just as NCERT loves to see us do it. Alright, so let us assume this bottle to be the pipe through which the unsegregated waste of the garbage mountain passes in order to get segregated. Now, here I have a few grains. Let us assume them to be the waste apart from plastic, and these are a few plastic particles. So now, with the help of a funnel, I'll be adding these grains, that is waste apart from plastic, then a few plastic particles, and then again some grains so that the waste gets properly mixed with each other. Well, now comes the moment of truth. As I invert this bottle in order to change the potential difference, this is what happens. The plastic has literally clogged onto the machine parts, causing the machine's failure. Now, since there are different types of machines for segregation of different types of waste, we here also have another miniature model for the same. And now, as we move it, have a look. Plastic has again clogged onto the pipe, or onto the machine parts. Well, see this picture out here. People are literally hand-picking the plastic waste, inhaling toxic gases like methane, simply because there is no other better way of segregation.
And mind you, this problem is just not confined to India. Countries like Bali, Vietnam, Cambodia or Thailand also find their positions in this list. So, here I have that same waste. Let me add some plastic particles to it. Carefully mix it. See, as I rotate it in the circular motion, set your eyes on. All the plastic has accumulated towards the center because of the centripetal force. This is a force that directs the objects towards the center of the circle, especially the lighter objects.
Now one can easily segregate the waste and the waste to energy machines won't clog anymore. Well, this can even help accelerate government initiatives like Zero Waste City and promote the most discussed idea of India's G20 presidency, sustainable development. Did you see how simple this was? We actually have no idea about the potential of normal-looking science phenomena in our lives.
Amazing, isn't it? So, now that we have explained you both the forces, let's get back to our Paheli story. Remember poor Paheli's messy mopping? This problem is everywhere experienced, from hotels as big as Taj to restaurant chains like Bikaner. Traditional styles of mopping create a lot of lather and to and fro movements of marathons of cleaning it. But don't worry, we are here at your rescue with a mop powered by the centrifugal force. So, let's see how it works. As I rotate this mop in a circular motion, all the lather will get accumulated towards the circumference that is outwards the circle due to our centrifugal force. I mean, we just learned it. And this collecting duct will simultaneously collect it, making cleaning much easier.
Well, that is the same centrifugal force that can also be used to replace heat-generating hair dryers, preventing skin and hair damage.
So, imagine this to be the platform wherein we'll keep the hairs. The main part is that it moves in a circular motion. Now, I have some hair sample. I will carefully tie it just for that experience.
Did you see those water droplets?
Refreshing, right? These water droplets fell out because of the centrifugal force. So now, can you guess that Bujo fell because of which of the two forces?
Oh, hello, I did not fall down. Your grip was so damn loose. How can you say so?
Ignore him. I know that you know that he fell because of the centrifugal force.
Well, these two forces are also deeply rooted in the traditional cultures all over the world.
Be it the salsa dance of Cuba, or the Garba of Gujarat and the Ghumar of Rajasthan. We see dancers in super fast circular moves. See that clip? Notice how she's moving in circular motions? And oops.
And then, due to her grip got loosened, that is why, due to the effect of centrifugal force, she fell down. Okay, now close your eyes and imagine a tornado. That debris from something as tiny as a plastic toffee wrapper to the roofs of huge houses. All right, open your eyes. Let's bring your imagination to reality. Here, I have a plastic bottle which is almost half filled with water, and now I'll add a few plastic particles in it to form that debris. All right, now I have the cap in which we have made a hole. Put on this cap on the bottle and then invert it, give it a twirl and have your eyes on. A tornado is being formed and all the debris is being accumulated towards the center of the tornado due to centripetal force.
And watch out, we can even prove the circular motion by the shape of the water coming out because it is rotating simultaneously.
Well, this shape actually reminds me of a cell's DNA.
Oh yeah. Hey, but why did we mention Christian Huygens in the beginning? Yes, you guessed it right. He is the backbone of the discovery of these forces. Did you know that the history of centrifugation goes back to 1659?
Centrifugation has evolved ever since and who knows what is to come. In 1659, the famous Dutch mathematician and scientist Christian Huygens coined the term centrifugal force in his famous work, The V Centrifuge.
Then, 200 years later, in 1864, Antonin, a German master brewer, had the idea of a dairy centrifuge. This is the perfect example of
necessity is the mother of all inventions.
But the truth is that this is not something new. Traces of these forces are even visible in the mythological stories, be it Krishnaji's favorite butter or Lord Vishnu's Sudarshan Chakra.
Hey, butter is understandable. But how come Sudarshan Chakra and centrifugal force? Never heard these two terms together.
See, we have always seen it revolving around his finger, right? And as he commands, it moves in the direction of the tangent towards the enemy. This movement of the chakra was due to the centrifugal force.
Well, that's amazing. We can also experience centrifugal force, the effect of centrifugal force on our hand when we rotate the Buddhist spring wheel. All right. Now,
As we approach to the end of our presentation, we would also like to present to you one more example wherein we use centrifugal force in applications such as defense. So, let us assume, let us have this.
So here, we have taken a wooden stick, a normal lace that we find at home, tied one end of it to a heavy tumbler and other to a super light plastic pen cap, just to maintain the weight difference. Okay, can you tell me what will happen to this tumbler when we release it just like that?
I mean, of course, it will fall down. No rocket science.
Let's verify.
Oh my God, what did just happen? Did physics fail? Oh, of course not, don't worry. What happened was, in this case, we released the pen cap in such a direction, that is in the direction of a pendulum. And while the mug was being fall down, a perpendicular force was also acting on the cap. This caused the cap to move in the circular motion, and then due to the centripetal force, it coiled around the wooden stick, preventing the mug's fall.
Now, just imagine the application of these forces going beyond the domestic or industrial sphere. Okay, imagine a normal scene often depicted in movies like Uri, Tejas or the newly launched fighter, wherein the soldiers are in a super important helicopter mission just to rescue maybe some important soldier.
Alright, so right now what happens is soldiers descend using ropes or ladders, which involves significant amount of risk and energy. To conserve this energy, we propose tying the soldiers to a rope and then directly dropping them down on the ground so that their energy is conserved. Just have a look. I think there is some problem with the length or the weight of the girl. Never mind, we'll solve that because of course that's a very important mission in defense. So now as we approach to the end of our presentation, let's hear some mind-boggling facts about these forces.
Did you know that in 1965, a machine was patented which used centrifugal force for the purpose of childbirth?
Pizza makers often use centrifugal force while tossing the dough into the air. The spinning motion causes the dough to spread into thin, even crust.
The centrifugal force applied on sugar when we rotate in a drum allow it to convert into the sweet cotton candy we all enjoy.
Now, we would like to share with you that we want to patent our innovative solution for the waste segregation so that we can help the society as a whole.
With this, we hope to contribute to our Honorable Prime Minister Shri Narendra Modi's vision of Startup India. Hashtag Made in India. Now, we would like to conclude our presentation with Every day is an opportunity for a new discovery, a challenge to unearth the miracles hidden in the ordinary. Thank you.
We now have Navya Puri of grade 10 and Myra Negi of grade 10 as well, representing Team B. Let's welcome them.
Good morning, esteemed judges and our dear audience. We are Myra Negi and Navya Puri of class 10 DPS Greater Noida. First, we would like to thank the organizing team of the Ministry of Education's Innovation Cell for giving us this golden opportunity.
But to learn is to enact. So we would like to start our presentation with a small skit about a mother and a son.
Hey son, how's the homework coming along?
It's going okay, Mom, but I'm stuck on this physics question about centripetal and centrifugal forces.
Okay, first you've got to look around yourself, okay? Do you remember the time we made ice cream in the summer?
Yeah, we put all the ingredients in a container and then spun it around in an ice and salt mixture to freeze it. But what about it?
I'll tell you.
What is she doing? Mom, do you need my help?
No, just right.
Whoa!
Do you notice how the mixture is on the walls of the container?
Yes.
Well, when we spin the container, the mixture is flung outwards due to the centrifugal force.
Wow, that is so cool.
Yes.
Mom, what are these handkerchiefs for?
Take this handkerchief,
Okay.
hold one end and spin it around fast.
Are you sure it is wet?
Just spin it around.
Okay. Mom, the water is flying everywhere.
Stop. Why do you think the water is being flung outwards?
Is it due to centripetal force?
No, it's centrifugal force. It's pushing the water droplets outwards against the center of rotation, and therefore we feel the water flying.
Oh, it's like the water droplets are trying to fly away from the handkerchief.
Yes.
That is cool. But Mom, what about centripetal force?
Okay. Take this other handkerchief,
Okay.
hold one end tight and spin the other end around.
Okay. Whoa. It is getting tighter and tighter by every turn.
Yes, that is centripetal force. It's pulling the handkerchief inwards, causing it to coil around and around, making it taut.
Wow, Mom, this is so cool. Like these simple objects have such complex forces behind them.
Yes, I'm glad you get it.
Yeah. So one forces pushes things out and other pulls them in.
Yes, it's such a yin-yang effect.
Yeah.
Now, I'm sure you've got a basic insight into these forces by looking at this conversation between the mom and the son. There are,
The textbook definition of centripetal and centrifugal force. Can you explain it to us, Myra?
the textbook defines centripetal force as the force keeping objects rotating in a circular motion and pulling them towards the center of rotation, whereas it calls centrifugal force the force pushing them outwards against the center of rotation.
But physics is not about words and definitions. Rather, it's about observation and experiments. So we have a journey of examples for you to explain them to you.
A perfect example of these forces is seen in nature. Have you guys ever seen a whirlpool? It forms in the smallest of glasses to the biggest of oceans. When we first start spinning the liquid, the force is not able to sustain the circular motion of the water. However, as we continue spinning faster and faster, the force increases, pulling the water inwards, giving the whirlpool its iconic conical shape. Now, when objects such as sea plants, fishes, or even swimmers are caught in the current, they are pulled inwards and they may even drown.
Wow, Myra, that is such an interesting phenomena. But I want to challenge you on something. Can you take this balloon and spin the coin around it? I bet you can't. Whoa, she can? God, I lost the
Do you
bet.
see how the coin rolls on the vertical walls of the balloon?
Yeah.
Why do you think that happens?
That is due to centrifugal force. Due to the centrifugal force, the coin is forced away from the center of rotation towards the vertical walls of the balloon. This is like the moth of Kua, isn't it?
It is. In the moth ka kua, the riders rotate around the vertical walls.
Wow. But while we're speaking of carnival rides, my favorite carnival ride is the roller coaster. Have you ever been on a roller coaster?
I have. It's so fun and exhilarating.
Have you guys ever been on a roller coaster?
I'm sure they have.
But have they ever been on a roller coaster with popcorns or snacks within their hand?
That is a dumb idea. It will literally fall down.
No, it wouldn't. Physics is always there for me. Now, why don't we take this cardboard as a roller coaster and this dibby as a popcorn? Myra, spin it around and let the magic happen.
Do you see how the popcorn doesn't fall down?
Do you know why that happens?
Centrifugal force, of course.
Yes. Due to the centrifugal force, the popcorn is pushed away from the center of rotation towards the bottom of the bucket, due to which it prevents it from falling. Isn't physics cool?
It is. Let's see that again.
Whoa.
And physics never fails us.
Of course it doesn't.
Have you guys watched the new Avengers movie?
Yeah, the Avengers Endgame, it is literally my favorite right now. The scene where Thor swings his hammer towards Thanos, oh my god, that is such a cool scene.
But do you know it has an example of centrifugal force?
Huh? Yeah, I know.
Since Navya clearly knows, we should probably explain it to you guys. When Thor rotates his hammer, it moves round and round, and then he throws it in a tangent to the circle. This is a classic example of centripetal force and inertia.
Of course, I knew that. But while we're in space talk, do you know what is the most interesting thing in space for me? It is the black holes. Recently, I read a documentary about it. It was literally so cool.
What did you learn?
Okay, so I learned how the matter falls into the black hole. Let's take this kadhai as a black hole and this Beyblade as a matter. Myra, please spin it around for us. Do you see how the Beyblade first goes throughout the walls of the kadhai and then eventually falls in the middle of the kadhai? This is due to centripetal force. In the black hole, the strong gravitational pull at the center makes the matter orbit around it. The centripetal force is responsible for keeping the matter in an inward direction towards the center of the black hole while balancing the increasing speed of the matter. Eventually, the matter crosses the event horizon, a point of no comeback, and gravitational force takes over the centripetal force, and eventually the matter falls into the black hole. That's how it works.
I mean, that was obvious.
Yeah, sure it was.
So black holes are interesting, but let's come back down from space. How are you guys into F1 driving? My favorite team is the Ferrari.
Who isn't into F1? But do you know F1 also utilizes centripetal and centrifugal forces?
It does?
F1 tracks utilize banking roads, or also called inclined roads. They have a slight slope in them to make the drivers go in a curve inside.
As the drivers move in the curved motion around the banked roads, the tires are pushed onto the road due to the centrifugal force created, and therefore they are prevented from slipping downwards. This is especially useful when they're making sharp turns at high speeds.
You know, I just love learning new facts about the sports I love.
Centrifugal force is used in sports, but do you know that these basic sports with like a one-line definition are also used in weapons of mass destruction?
Huh? What are you talking about?
Let us take the example of an artillery shell. Artillery shells contain a fuse with a striker and an initiator, kinda like a matchstick and sandpaper. When the striker hits the initiator, it causes a spark, leading to the combustible material to ignite and causing a blast. To ensure there are no incidents due to mishandling, we have a centrifugal safety arm between the striker and the initiator, which acts as a physical barrier, preventing them from hitting prematurely. When the missile is launched, it spins.
And you can see how it sticks away to the sides of the wall
Due to centrifugal force created when the missile is spinned. This leads to the eliminating of the physical barrier, and the fuse can now perform its function without any problem.
That is such a cool topic. I have never learned about it before. But Myra, why has your skin been glowing so much recently?
I did something called a vampire facial. Do you know what it is?
A vampire facial? What are you even doing?
Well, the blood is extracted from a patient and spun around at very high speeds. This leads to the platelet, which is lighter in weight, to settle atop the heavier blood components. Now the platelet is extracted and used for skin therapy.
Maybe I should try doing that as well.
You should, it's really helpful.
But now can we come down from all this warfare, ocean, space and facials to our own living rooms? Do you guys have a vacuum cleaner at home?
I'm pretty sure they do.
No,
now, vacuum cleaners utilize a special type of fan called a centrifugal fan.
Okay, let's take the fidget spinner as our centrifugal fan and our coin
as an air particle.
Yes. Now, when we spin the fidget spinner, there is a difference in air pressure due to which air is let in.
Let us keep our coin on the fidget spinner and spin it. Do you see how the coin went from this direction to that? When the air moves in, it is deflected and changes direction due to the centrifugal force created by the spinning of the fan blades.
That is interesting.
It is. Did you know that?
I did. Okay, stop. Okay, do you know, I have been recently getting into a lot of art, and my favorite art style is the spin art. Do you know what it is?
No, I don't.
The spin art is basically a very new trend in which the painters pour all of the paint onto a canvas, in the middle of the canvas basically, and then spin it around in high speeds, due to which the paint goes everywhere. Each time we create a very unique and one-of-a-kind piece. That is why it has such of a hype.
That is so pretty. Who could imagine something like physics being used in art? To conclude our presentation, we would like to say that physics can seem like a very intimidating subject. I mean, when I was in class 9th, I was extremely scared to start physics. Then I realized that it really isn't that complicated. All I had to do was look around me and realize where all these concepts are used.
Centripetal force and centrifugal force is literally in every sphere of life around us. From the washing machine in our bathrooms to the helicopters we see flying around in the air all day long. But to learn physics is our choice, how we want to learn it. Either we want to cramp up all the definitions, or we want to stop, look around, observe and learn.
As physics is not a subject about definitions and words, rather about experiments and observations. Like Albert Einstein said, it is just important to never stop questioning, as questions lead to answers and answers lead to more questions, and they let us discover all the secrets of the universe.
I hope you all know all about centripetal and centrifugal force. I hope you all do. We explained it very goodly, okay? So, should we go away now?
Yes. Thank you.
Thank you.
And now it's time for the judge's opinion.
In the second topic, centripetal centrifugal force, the runner-up is DAV Public School Sector 49 Gurgaon. The participants are Shwetank Agarwal and Mukul Yadav.
And the winner is Delhi Public School, Greater Noida. And the participants are Vidhi Rao and Samishta Jindal. Congratulations to all the winners.